If your team's trying to move faster with AI or scale more efficiently without reinventing the wheel, InfoQ Dev Summit Munich 2025 this October 15th and 16th might help. It's a practical event, talks from people in the trenches, sharing what they've actually shipped, fixed, or learned. No big launches or buzzwords, just useful ideas you can take back to your team the next day. Learn more at devsummit.infoq.com.
Hello everybody, I'm InfoQ Pop, an InfoQ editor, and I have with us today Sam Newman, as people call him the father of microservices, or the person that coined the term. Without any further ado, Sam, can you provide us an introduction to you and what you're currently doing?
I work as an independent consultant and trainer. I kind of work with companies all over the world doing different things, really. I don't focus just on the area of microservices, but typically I work in the area of helping teams change their architecture or change what they get from their architecture. I'm also in the process of writing a book on making distributed systems more resilient. And I also need to be really clear, I did not coin microservices. I was in the room when the term was coined, but I'm certain it wasn't me that said it.
Okay, great. Thank you for clarifying that. Nevertheless, whenever I think about microservices, I think about the book that you wrote a decade ago. I was just checking earlier, and yes, there are 10 years since the first edition of the microservices book. And that's what I'm thinking. Whenever I have to think about a system, I think about your book. And probably the main reason is because it's a very focused book. It's not very thick, and it has a very nice cover. And if I look at the chronology of that, you have the first book 10 years ago. Then 4 years ago, you had your second edition. What changed on that time span?
Well, the second edition is a thicker book. So I think that needs to be clearly said. I mean, firstly, the first edition, I think, and the second edition, the core concepts are the same. So the focus on an independently deployable style of service-oriented architecture, focused around business capabilities, treating kind of microservices like black box, being technology agnostic, avoiding database integration, focusing on loose coupling, the importance of domain-driven design. Those are all elements that flow across the two books and kind of in terms of the kind of core ideas and the core principles. Those haven't really changed. But a couple of things happened. I mean, firstly, some of the things in that first edition were a little bit speculative, as in we were still drawing on a smaller number of case studies. So although service-oriented architecture has been around since the mid-90s and microservices are just a type of SOA, we were really looking at organizations using service-oriented architecture in the microservices style, and there weren't as many case studies to draw upon for that work. So I didn't have as much of a richness to draw from experience from. This was the days where we thought containers might be a good idea, perhaps. And so I mentioned them in there. So there were some areas where we kind of firmed up on how we want to do random deployments, for example. We also had a lot more case studies out there, but also a lot more time spent talking to people, talking to companies, working with companies, seeing these ideas put into practice, realizing that a lot of what I thought was quite obvious was maybe too implicit in the book. For example, I talk in the book, the first edition, about how you should break apart your user interfaces. I say you should do that. And I kind of give a bit of an outline, but I assumed people would do that work, and they didn't. So like in the second edition, I wanted to firm that up. There was also some old ideas that just resonated more with me the more I sat with them. So for me, like the importance of information hiding really just kept rattling around in my head. I remember Martin Fowler helped review the first edition of the book, and he mentioned it to me. I think I mentioned it in passing in the first edition. But the more I thought about it, the more I thought this in many ways is kind of so key to the discussion. And so I wanted to go back in and be more explicit in my advice, draw upon more case studies, to an extent cover new technologies, although I tried to make it a little bit timeless in that sense. But I also really wanted to bring in some firmer mental models for thinking about the modularity effectively of microservices. So for me, the chapter I'm happiest with is the second chapter of that book, right? Where I feel like I've done the best job I've ever have of bringing together the ideas of microservices, domain-driven design, coupling, cohesion, and information hiding. And it all kind of makes sense, right? For me anyway. And so that chapter was worth the second edition alone, even though that whole book ends up being twice as big. So principles same, I think hopefully more clear, more explicit, more case studies. That would be kind of the main difference. And in some cases, we got it translated into a couple of different languages, I think, than the first edition. So hopefully it reached a few more people.
Nice. Thank you for that summary. So let me see if I can extract the gist of it. Basically, what you're saying is that You started from something that was very conceptual initially. You're just imagining things, how the things might look into a distributed ecosystem and how are the things coming together. Then the second edition started being more concrete. People started using it, and then you came back with case studies and extracting the gist of those things.
Yeah, maybe not conceptual. I think it was conceptual in some areas. So, for example, when talking about the container technology, it was speculative because there were very few people playing around with things like LXC. And so, I mention it in the book, but it's quite early days. It was pre-Docker when I wrote that edition. So there's some of that stuff is speculative. I think as well, there were some areas that were a little bit speculative. It was around the testing. So I kind of had got to the point where I realized that end-to-end testing was extremely problematic for systems with much larger kind of scope, more distribution. And so weirdly, that chapter ended up being quite controversial in some circles because I basically said, you probably should stop doing end-to-end tests for larger scope systems. Like when you have more than 2 or 3 services, fine. One team, fine. That got a lot of pushback. Certainly inside ThoughtWorks at the time, there's some people that are really angry at me for saying you shouldn't do end-to-end testing. It's like, well, but also the number of case studies are there. So, the 2 main case studies that I draw on a lot there were from Netflix, and Ben Christensen was very kind enough to review the book, who's looked after sort of performance on and resiliency on the AI API side and REA in Australia. So just being able to hear people's stories, working with more clients myself, you get to enrich that. A lot of the book is around trade-offs. And so I can say, here's some trade-offs generically about a certain idea or a certain way of doing something. But the power of a case study is that it's a real story. It's something that somebody did. I can talk about the trade-offs they made, what did work, what didn't work for them. And I've realized kind of over the last 15 years or so that being able to tell real stories is very important because they stick in people's heads in the way that maybe contrived examples or theoretical things don't. And so, again, I wanted more space for those stories to help them stick. And I'm incredibly fortunate that lots of people were very generous with their time in terms of sharing their stories. And this is just a call out for anyone listening to this podcast. Like conferences, you need more case studies. Please, if you've had a fun story at work, do a talk about it because everyone can learn from your experiences.
Thank you. So while listening to you, one thing was going round and round in my head. Because during this decade, and I was just thinking that, 10 years ago, we didn't have Docker. And now Docker is already moving away from the limelight and other ones are coming. And then you mentioned database integration, and that's a clear anti-pattern from multiple perspectives. What does it make a microservice? To just put it like a short definition.
Well, okay, let's talk generically about what a service is in a service-oriented architecture. It's a program running on a computer which communicates with other services via networks. So a service is something that exposes interfaces via networks, talks to other things via networks. That's a service generically, right? A microservice is one of those where it is independently deployable. So I can make a change to it and I can roll out new versions of it without having to change any other part of my system. So things like avoiding shared databases are really about achieving that independent deployability. And it's a really simple idea that can be quite easy to implement if you know about it from the beginning. It can be difficult to implement if you're already in a tangled mess. And that idea of independent deployability kind of has interesting benefits because the fact that something is independently deployable is obviously useful because it's lower impact releases. But there's loads of other benefits that start to flow from that. And so it's a type of service which is independently deployable. That is a microservice.
Okay, thank you. With or also with the organizational benefits, because it seems that most of the people, when they are speaking about microservices, they bring into the discussion also Conway's law and the way how the organization of their enterprises is depicted by the architecture of the systems. So what do you think? Does it have an impact?
I think it's almost a truism, as in it is an observation that was made back in the late 1960s, which we found to be true on so many occasions, that the architecture and the organization end up matching. And typically, it's the organization that drives the architectural shape. Every now and then it works in reversal. That's rare. So that's just almost like, as far as I'm considered, as close to a fact as we get in computer science, where we don't have evidence for it, right? We don't have evidence for lots of our facts in computer science. So for me, it's like, that is true. So then the question is, well, what does microservices have to do with that? Well, the reality is that because microservices are focused typically around the business domain, and we know our architecture follows our organizational structure. And we know that there's been a shift over the last 10 years towards more product-oriented organizations, where we expect a delivery team to be more aligned to the business organization, then it's almost like the microservices architecture is ready and waiting for that shift. So for me, it's more about, we've got companies that want to move towards more product thinking, that want teams structured around business outcomes and more closely aligned to the business. That's happening, right? We've also got organizations recognizing the importance of teams having a higher degree of autonomy, because they're recognizing that if they just add more people but keep that bureaucracy, then you add more people and you can go slower sometimes, right? So wanting more autonomous teams to get more work done with the people you've got. So these are all the things that are happening. And microservices as an architectural style is ready to help all those things happen. So in my experience, certainly with the enterprise organizations that I've worked with and with the scale-ups I work with, the single most common reason for using microservices is to enable a certain style of organization. The vast majority of people who tell me they've got scaling issues, they don't really actually have scaling issues. What I mean is they could solve their scaling issues with a monolith, no problem at all. And by the way, it would be a simpler solution. They're typically organizational scale issues. And so for me, it's like, what the world needs of our IT is product focused, outcome oriented, more autonomous teams. That's what we need. And microservices are an enabler for that. And, having things like team topologies, which of course, although the DevOps topology stuff was happening around the time of my first edition of my book, that being kind of moved into the team topology space by Matthew and Manuel around the second edition, again, sort of helps kind of crystallize a lot of those concepts as well.
Okay, thank you. So I heard a lot of the points that are important these days, in my opinion, like product thinking mainly, because we engineers like to talk about technology, and I think that's misses the point altogether. And that goes hand in hand with the domain driven and also autonomy. So what you said, basically, if I got it correctly, is microservices as an architectural style allows us to be more autonomous and deliver values for the organization and make it leaner, basically, without all the fluff around it.
Yeah, and I think that's absolutely the case. I think then the second question is the cost of microservices worth those benefits? And could we get some of those benefits without that cost, right? And then I think that's what's very healthy, is that some of the concerns around the cost of the complexity of microservices has led people to saying, what about this new thing called a modular monolith? Which I think is wonderful because, again, a concept from the 1970s, right? Well, actually earlier than that, right? Modules. And so do I think you can achieve the same kind of organizational autonomy with a modular monolith as you can with microservices? No. However, you might get enough by reducing the downside, right? So I'm glad we're now having a more healthy debate around these sorts of things. Because in many ways, the thing that the software industry is still incredibly bad at in general is modularity. Microservices, when done right, are a modular architecture where a decision has been made to put a module over a network boundary. So for me, it's like, I'm glad we're now having these conversations. I think the big problem is we have a lot of organizations, and this is not new, that just assume they have to use microservices, that there is no debate. That's the architecture we're picking, that's the default state, and that a monolithic architecture must be bad. And that's something I pushed against in the first edition. That's something I pushed against even more strongly in the second edition. So while I can talk about all the good side things that microservices bring, I kind of also describe microservices quite a lot as an architecture of last resort, because there is a lot of complexity that comes from building a more distributed system. And so if I can work with a company and help them solve a problem with a nice, simple modular monolith, that's absolutely where we're going to start, because we don't need everybody to be using microservices. And I think there's a lot of people that are using them would be better off without them.
Well, I didn't want to ask this question, but somehow the way how you responded pushes me to, so I have to ask it. Which is the scenario when you shouldn't use a microservice, when most of the people are wrongly adopting it, even though they shouldn't?
The simple answer is when you don't have a good reason to. Now, of course, that sounds silly, but what I mean by that is one of the first things I do with people is ask, why are you using microservices? And they can't give me an answer. Or the answers they give are all quite insular focused. They're like things for reuse. That's not an answer, because reuse is a second order benefit. Like, why are you doing this? If you're picking an architectural style or moving towards an alternative architectural style, then I think it's very important that you understand why. What outcome are you reaching for? Do you know why you're doing this? Because then actually when you get down to, okay, well, we want to do this because we need our application to be able to handle the load we've got. And that's why we pick microservices. Okay, great. Did you look at a simpler way to solve that problem? Did you consider getting a bigger machine? There's nothing wrong with a bigger box. Did you consider running 2 copies of your monolith behind a load balancer? Did you try that? Because maybe that would have been a good idea first. So for me, it comes back to the goal, right? It comes back to what is the outcome you expect that architecture to bring. And if you don't have a good reason, you shouldn't be doing it. Now, I think additionally, there are certain scenarios where I think microservices tend to be even more a suboptimal choice. Now, of course, all of this advice is general. There are always exceptions. I think too many people think they're the exception, but there are certain scenarios where I think microservices are even worse an idea. I think early stage startups, it's a waste of time, right? You've got not enough time, not enough people. You don't know if anyone wants to use your product. Put your time and energy into that. Don't put your time into building a scalable system that's going to handle your success if you've got no idea if you're going to be successful, right? So don't waste your time there. Second area is where the domain is really new. Getting module boundaries is difficult if you don't understand the domain. If the domain is very new or highly emerging, stick with a modular monolith early on. The third area is if you, and this is increasingly more of a niche, if you are shipping software to a customer that they're going to install and manage, microservices are a nightmare in general, so don't do it there. Those are kind of the areas where I'm saying, look, you have to do every single thing you possibly can to convince me this is a good idea. But for me, and this is all I do to sit down with teams, it's like, what is the outcome? And I will say, we sort of talk about microservices like it's a switch, like you're either doing it or you're not. It's much more like an extent or a degree or like a dial you're turning. So you can go full microservice, right? And then you can go, we've got 1 or 2. For me, there's a lot of spectrum on that, right? So you look at a company like Monzo, where they've probably got 10 microservices per developer, some of the more extreme ratios that I've seen. Other organizations, they have 10 developers per microservice. That is an ocean of difference in terms of the complexity and the challenges you're facing. So for me, it's always about being very focused on that outcome. Like, what are the things that we need to achieve for the business? Have those things we need to achieve for the business changed? Does that mean we need to change our approach? Rather than saying somebody laid down a decision about an architecture we were going to pick and we're just sticking within those tramlines. No. It's a constant reevaluation of what are we doing to achieve the outcomes. So maybe you don't need to keep turning that microservices dial up. And maybe sometimes the answer is to turn that microservices dial back down. I think swinging wildly between 2 extremes is unhealthy.
So to just try to squeeze that in a phrase, what you're saying is that it's more about the journey rather than the destination. It's not you, depending on the state of your business and what's your target as a business. You might go more microservice or less microservice depending on the context.
Yeah, I like that phrase, the journey, because let's be clear, if you view architecture as a destination, you're starting off with a fundamental flaw in your thinking, which is that architecture is fixed. So if you view architecture as the destination we've arrived, that implies it's static, it won't change. And that is not the right way to think about architecture. Sure, architecture can be hard to change. You should always be changing it. So architecture is always a journey. So for me, like that business outcome, what the users need, what my business needs, that's my North Star constantly. And we're always weaving towards it. What do we do next to get there? What do we do next to get there? Having a vision for where you think you might be in 12 months, 18 months, 2 years, absolutely fine. No problem at all. Recognize, of course, you might be wrong about that. Architecture is always a journey. It always is changing. It should always be some sense of flux. And if it isn't, I think you're probably storing up pain in your future.
So the bad news for the hardcore techie guys is that it's more business focused. We have to look at the business metrics and what we actually want to do with our software system. And because you touched on that as well, we need to look more into evolutionary architectures and the way how they evolve depending on the time. And that beats a quote from Neil Ford that I heard also at QCon from Luca Mezzalera's talk, where he says that reusability is also a way of tightly coupling our systems. And basically, can we say that a potential journey, a potential path towards a goal can start simple with a monolith, make a proper separation of concerns in terms of modules, and depending on the context, you can break those modules as microservices if you need to scale partially those points.
Absolutely. And my advice has been for, again, over a decade now, start with monolith first. If I was starting a project today, it would be a monolith. If I was on startup today, it would be a monolith. For me, I have to have a reason. I have to be convinced that now is the time to split off a service. Running and operating a more distributed system has a cost, right? Another analogy I've used for this is to think about like medicine. So when you go to the doctor and there's something wrong with you, they might give you some medicine. Like, oh, my leg hurts. Oh, okay, well, I'm going to give you a pill and that pill's going to stop your leg hurting. Great, I've solved my leg hurt. And then the doctor says, by the way, there are some side effects. There's a 1 in 20 chance your leg might fall off. And then you get to decide, how bad is the pain in my leg? Do I want a 1 in 20 chance of my leg falling off? And I'm being obviously, it's not, I don't think there's any drug that would do that to you. But there is this idea with medication that you have the side effects. And I think the issue is that because we're not thinking about the outcome, we don't have a sense of the benefit. So we don't know about the leg pain. But we're also not always being rational about the side effects. And when you don't have a clarity around those two forces, it becomes very difficult to know, should I take that pill or not? Which is also why I give strong advice to all people who are thinking of adopting microservices is like, if you think it might be a good idea, but you're not sure, actually, there's nothing wrong with starting. There's nothing wrong with doing one. You've got a monolithic application right now. What if you created one microservice done using the right microservices principles, get it in production, get it being used, and learn from that process? Actually do it in anger. Because I think the other side to this, which is a bit where it becomes challenging, is that I can talk theoretically about the challenges that microservices might bring, but I can't predict exactly which one you're going to hit on which day. Some problems you might not experience for years, some you might hit you on week 2. There's so many different variables there. So if you think microservices might be good, just start with one and get it out there and see what happens, and then learn from that. I think the challenge often in enterprise organizations, especially, is they say things like, we are going to do a microservice transformation. And I've told my boss we're doing a microservices transformation. And I have got a lot of money to do a microservices transformation. Sam, please come here, talk to us about our microservice transformation. And I get there and say, I don't think you should use microservices. And they're like, but I told my boss we're doing microservices. That now you're trapped. I have got into more than one client where I have been used as air cover to explain why they're reversing charge on the microservice transformation. Screw microservice transformations. Don't talk about that. Talk about an outcome-driven approach. So a couple of my clients, they're saying, our transformation is we want to move to more autonomous teams. So that's the outcome. We're moving towards more autonomous teams, and that's our sort of our North Star. What do we need to do that? So then that gives you a lot more air cover. So more autonomous teams could be maybe microservices in some places where it's appropriate. In other places, it could be reducing the need for tickets and doing things that are more self-service. So you then give yourself wiggle room, because if your North Star is scaling the system, more autonomous teams, you can try microservices, don't work out, you can try something else. You don't have to go back to your boss and say, we screwed up, we made a mistake, we're not doing microservices anymore. So you don't have to burn that political capital. So if actually you structure these things as outcome focused, you give yourself so much more wiggle room to try things, to change your mind, to learn and adapt. And I know full well I'm doing myself out of work here. Please hire me for your outcome-driven initiatives. But I hate it when people say it's a microservice, because that is like saying we're doing an enterprise service bus implementation. It's like,
Who cares?
yeah, who cares, right?
Exactly. Okay, thank you. So that's nice. And that was my feeling also at QCon. Before QCon, I attended QCon, and I was very happy when people were talking about user experience. You know, you have these hardcore guys that usually used to be site reliability engineers for not long ago, and they were thinking about only in terms of boxes. And now out of a sudden, they were just talking about the user experience of that user or that group of users on that percentile. And I was like, wow, it's actually happening. People are actually thinking about outcomes. Well, it was a small part of the presentation group, but hey, I'm very happy to hear that people are finally getting to that point. But given that we spoke about two of your previous books, let's speak about the current one. What was interesting was you had 3 points that you focused on during your presentation at QCon, and those were retries, timeouts, and idempotencies. And that was really nice, because for me, what I'm saying, especially with this generative AI hype and whatever, wave of hypes because it's like a tsunami. It's not over and another one is starting. And it's getting back to the basic stuff. And it's important to understand the basics and to build again. And it was very eye-opening for me, the way how you looked at it in a, again, outcome-driven, focused on real data, especially I'm thinking now, especially on the retries, the number of timeouts, not the number of timeouts, but the span that you'll use to configure your timeout. But what I'm thinking now, and it's stuck in my head as a question is, what happens with the data consistency, for instance, or all the other stuff that usually happen in the distributed ecosystem? Because in the end, data, well, people say that it's the new oil, it's the new gold, whatever. It's the one that drives the application. What are the things that you will probably touch in your book that we still have to focus on? And maybe just come up with some heuristics on how we can decide those things, leaving technology aside.
I think the problem is a lot of the discussion around the complexities of distributed system are either use my magical framework and I'll solve all your problems and you don't ever have to worry about there being a network, which is fundamentally a lie. Hello, things like Dapper, right? Oh, I pretended the network doesn't exist. It's like it does. Or there, let me do a whole hour-long presentation about Byzantine consensus protocols. And it's like, just kill me now, right? This is going to break my brain. And I think we get like oversimplification in some ends in the wrong way and over complexity in another way. And I think the reason I meant oversimplification is a lot of our technical solutions will often try and hide the reality from us to the extent where we have lots of developers that, through no fault of their own, are sort of living in a world where they don't really understand what can go wrong. But at the same time, it doesn't mean they should understand the nuances of cap theory or be able to debate harvest and yield or, talk about the nuances of Raft versus Paxos or anything like that. Use Raft, obviously. So for me, I was like, okay, so I try to think about a persona for the book. The reason that the second edition of Building Microservices is so thick is because that book is mostly about the pain of microservices. If you're going to do this, here's all the things that could go wrong. Here's how you handle it. That's why the book's so thick. And so kind of in that spirit, I wanted to think there's lots more people building distributed systems than in the past. And the degree of distribution is increasing. So if I was a developer who suddenly found myself on a project where it was a distributed system, what would I need to know? And so I'd want that book to be a journey. I want you to start with the fundamentals and take you through. So yes, we are going to talk about more complicated things. I'm just finishing up the chapter where we're talking about like why exactly one's delivery is potentially a fool's errand and all that kind of stuff in how message brokers work, right? So kind of the persona I might have actually had was my son, right? Quite new, working as a developer on a project where they're doing all this stuff. And it's like, what the hell? What's going on? I was like, what is a rubber ring in book form that I can give to all these drowning developers that are like being swamped by this challenge, this complexity? So I kind of start right in the beginning, and the book's in two parts, right? Part of it is about the human side of the human factors. And I frame resiliency very much in the kind of context of a socio-technical system, which is our software is people and technology working together, right? If you ignore that, you're in problems, right? So I discuss things like safety management, resilience engineering, the difference between those things and everything else. But talking about like the simple heuristics, the simple stuff, actually, what is it about a distributed system that hurts? What is it actually fundamentally about a distributed system that causes all of this pain? It's actually three things. It used to be two. I found out the third thing, right? One, it takes time for stuff to go from A to B, and that's only partly under your control. Two, sometimes the thing you want to talk to isn't there, and that's only sometimes under your control. And three, resource pools are not infinite. Fundamentally, if you always have those things in the back of your mind, all the rest of the stuff we talk about is just a logical extension from that. So recognizing that those things exist, and then the question is, what can you do about it? So for me, it's like I want to take you on kind of that journey. I don't start off talking about things like eventual convergence or anything like that in that book necessarily, because that's a logical extension of those ideas. And so in my talk, it's timeouts, retries, idempotency. And that's because that's literally effectively the first two chapters of the technical side of the book is, okay, if it takes time for things to go from A to B, and sometimes the thing you want to talk to isn't actually there, you need to give up. So let's talk about how you give up, which are timeouts. If you're going to give up, we need to talk about trying again. We'll talk about retries. If you're going to retry, you need to make retries safe. So let's talk about idempotency. So I always try and write my books in a way that they're topic focused. So you could read one chapter and it makes sense. But I'm also trying to take you on that journey. Then we get on to things like rate limiting and load shedding. So how do you handle it having too much load? And then it gets more and more complex into that kind of section. But I think just boiling it down to the essentials, it's those 3 rules. It takes time for stuff to go from A to B, and it's not instant. Sometimes the thing you want to talk to isn't there. Oh, and by the way, resource pool's not infinite. And that's it. Really, that's it. And then this book is all about, what's that mean? What are you going to do about that?
Okay, so what I hear from you is we need to make very simple systems. Well, simple in the way how we interact with them. And making things simple is hard. And pretty much that's basically it.
Well, there's a more general point here is that we need to make it easy for us to understand what our system is doing. So that means if you've got a complex system or a simple system, it doesn't really matter. Because ultimately, if a system is simple technically but hard to understand, then it's a complicated system as far as I'm concerned, right? So for me, there's that. So I am talking about observability from a resiliency standpoint through the book. Mine is really more simple, that is kind of almost at the more fundamental level, which is like a timeout. Oh, okay, I can do timeouts. I use resilience for J, or I use poly, or I use Dapper, and it's going to do timeouts on me. What do you mean do timeouts for you? What does that mean? Oh, it handles timeouts. Okay, so does it magically know how long to wait? Does it know if waiting too long is going to cause resource saturation and cause your system to crash? Probably not. Does it know if waiting too long is going to cause your customer to be annoyed? No. If you retry too quickly, right, then you hammer the services. So you could have a tool that does that, but you need to know how to configure that. You need to know how to take the user experience, expectations of your users, understand the resource saturation, because resource pool's not infinite, and use that information that you have to gather as a human being to take a look at these great tools and know how to use them well. Like resilience for J is brilliant. Poly is great. And a lot of the Poly stuff is now in the latest versions of .NET. Really great stuff in there. But it's a toolbox. And as a developer, it's like, oh, which bit do I pick up now? Right. And I don't think it is actually that hard if you kind of brought it down to those fundamentals. And I think that firm foundation, I think, stands people in well. But there is also part of that, which is, I think, this is the stuff that we've talked about in terms of my talk, is like, if I need to know how to set a timeout, I probably need to know how to look at a histogram. I probably need to look at my system behavior and understand what it's doing. And so for me, that comes back to, we need our systems, whatever it is we're building, we need to make it as easy for those systems to be understandable as possible. And that's why the observability stuff that I'm sort of weaving in at the moment is going to be such a big part of the book.
That's what I was thinking of, is that, as I said, it sounds very simple. You have a histogram, and then pretty much you just focus on the middle ground, more or less, and then you take some decisions. You have those that are very fast, and then you have the ones that are very slow, more or less, and then you just focus on the bigger majority.
Yes. But the but's big, right? Because the key thing is you focus on the middle majority in terms of, that's where you start. And so like the old classic thing is, I might, I have tail latencies, and maybe initially when I'm getting myself sorted, I might potentially time out before those tail latencies, right? And sometimes that's the right thing to do from a system health point of view. Once you've sorted your system out and your system isn't falling over, then you should probably work out why you've got tail latencies. Okay, because the tail latencies are typically users. So for me, it's like, there's going to be a discussion of tail latencies in the book, why they're there, what you should do, why you should worry about them. But I also say early on is, if you trying to accommodate tail latencies risks the health of a system, then yes, time out before there's tail latencies. Because those tail latencies typically they're humans, right? That's why it's a journey you go on, right? I mean, starting to talk, you don't talk about request hedging in chapter 1 of a book like this. Actually, most people don't do request hedging anyway. And for developers that know, they can jump into the middle chapters where it's more complicated and advanced if they want to.
Yeah, that's what I was thinking of now. Like tail latency. More often than not, it's more or less rotation based. It's round robin. It's not always the same individual that is unlucky enough to get a timeout. How should we envision that thing? If I'm really unlucky and I'm always in the tail latency, where should a decision be taken? Because we spoke about the outcomes, and obviously when you're discussing a business level, you're discussing broader level. So any thoughts on this?
So I think if you are seeing a certain user or group of users that are consistently experiencing poor latency, then the first thing is, can I get that information out from my observability tool? And this is why observability platforms that support quite high cardinality can be useful, because then I can associate a username or a user cohort identifier with those metrics, right? And I can get that analysis out. So that's why, I like things like Honeycomb for that purpose. So say I'm seeing a user group that is consistently having higher latency. Well, then the next thing is, what information do we have about that user group that might help me isolate what's going on? Sometimes the issue is we don't have the data, so we need to add it in. But examples of where you might have high latency could be you've got a sharded system and there's a problem with one of your shards, right? That's a pretty obvious one. And again, that's why the drill down is important, right? Looking at the average response time of a database cluster is useful, but if you want to drill down and look at an individual shard. Second reasons could be location based. So is it a part of the world you're serving not so well? Could there be some caching that could help? Is it just that they're in Singapore and you happen to be in Iceland and that's always going to suck? And maybe you say that's kind of life. I've had some issues before with specific ISPs having issues where ISPs were doing weird things around their cookies, which were calling like lots more redirection flows to happen. So the key thing though is firstly is spotting it. So that pike, is it a user group that is consistently seeing poor experience? And in which case, then you've got actually, I think in some ways that's healthy. Then you can add the data to find it out. If it's inconsistently you're seeing those outliers, then it still comes back to me for looking at those outliers. And that's why kind of, again, using an observability tool that gives you the appropriate ability to handle how you're doing your sampling. So for example, making sure that you're doing tail sampling. So you decide at the end of a capture of a trace, whether you're going to keep it or not. So anything that's going outside of your norms in terms of how long things are taking, you're capturing those traces. You can gain a lot of information. Sometimes you can see tail latencies because they're just unfortunate enough to have a whole lot of cache misses along the way. That can be a good reason sometimes where it happens. You can also sometimes have tail latencies to say on a JVM-based system, you hit a node that was just spinning up and it took a bit longer to respond. That happens. But again, if you're capturing the traces, you can then dive in and sort of find out what's happening. As you get more and more data, you might see more and more humps. Right, so if you see like clear patterns, like we've got a nice bell curve, and then there's a big gap, and then there's quite a cluster. Well, that probably tells me there's a bunch of stuff here that could be really, really interesting. And sometimes you get the hump on the other side, right, as well, which is like, these were really fast. What's going on there? We should double check that that's something weird didn't happen. And for me, it's more, and this is the kind of key to observability as a concept. I need to have the data available for me to ask questions that I didn't know I was going to ask. So can I explore? Can I gather? Can I tease these things out? If I don't have the data I need, can I add that data back into the system to start understanding what's going on? And it's also about having a tool chain which allows you to build the views that help you get those insights quickly as well. And that's another part of it. And that's where kind of the sort of the cold hard, like, we support open telemetry, has to give way to, well, actually, what does that tool let you do with it? And I think for me is that can I explore what's going on here effectively enough?
Okay, thank you. But it seems that observability is one of the key points here, having a lot of data and understanding of your system. But obviously, observability is not exactly the first thing that people think about when onboarding on a project, or even for more mature projects, observability is hard to achieve. How would you recommend getting started with a new project to have that insights about your system and to be able to take those decisions?
I start on day one with some fundamental things. So I said this in both editions of my book, right? The very first thing I would ever put into a system is log aggregation. That's often a prerequisite. And I would follow that up with saying that you start off from the beginning as using open telemetry for capturing your metric and trace information. So get an SDK for your language for OpenTel, put that into your code, use that from the very beginning, use that for capturing trace information. Open telemetry, you can have a variety of different vendors, open source, non-open source. You can always change your mind later, get that in early. Log aggregation, I still suggest doing a separate system for log aggregation because although theoretically open telemetry does support logs, I think practically speaking, I don't know that there's the degree of maturity we would like around open telemetry and logging. I think it's less the protocol, more the tool vendors, if that makes sense. So that's kind of definitely where I'd go. I think also logging can be quite useful if you've made a decision to pick a open telemetry collector that has low cardinality, which again, pick one that can support high cardinality. Hello, Honeycomb. But if you're going low cardinality, your logs are even more important. So doing those things early. Log aggregation, definitely day one. Get every service logging a consistent format. You can use log forwarding agents to reformat logs. Don't, because it's really expensive to do that. Do get them logging properly in the right format. Start with structured logging. So don't do semi-structured. The world's moved on. Use structured logging. Makes all the logs more queryable. That's day one. And from the beginning, again, open telemetry inside your services for instrumentation. And at the very beginning, you might only use open telemetry for ingress and egress of a service endpoint. so that you can track start and end times, response times, things like that, and outbound calls. And then later on, you can do things like adding open telemetry instrumentation for things like database calls and things like that if you would like. I would say around the same time is be really clear and upfront about what information you're happy to capture. You know, I think a good starting point is not to have anything that's personally identifiable in a log or an observability tool. Just don't emit it in the first place. Don't use scrubbers. Just don't put it out. If you don't put it in a log, you don't put it in open telemetry, you don't have to worry about where it goes. So again, that is something I would get sorted out at the very beginning, get it in as a principle. So those are probably the three things I would start with. Log aggregation, open telemetry, don't put PII into either, and just do basic ingress and egress, and you can always add on more stuff afterwards once you've got that in place.
Okay, thank you. So what I hear from you is start with discipline in the way how you do it across the board to have queryable logs and start with those, because otherwise it will be more complicated. Just think upfront to make sure that you don't have PII to avoid headaches later down the road. And after that, continue on the road to, let's say, more implementation or a complete implementation for OpenTelemetry, where you can just instrument database calls and stuff like that.
I would also just say, like, you want everybody using the same pane of glass. What you don't want is 5 different teams all using OpenTelemetry, but all using their own OpenTelemetry collector. You need one collector because the whole point is seeing the correlations and the traces. Yeah, get that scaffolding in early, and you can always add that information. You realize, oh, I wish we knew about X. Well, now we've got the basics. We can go add that in for next time. So yeah, probably alongside that, I would say is these are other just general principle things. You want the same tool chain in all your environments. So in your CI environment, if you have like an environment, you can see what's going on, or a QA environment or a dev environment or whatever it might be, same tool chain. I want the same log aggregation tool. I want the same observability tool. So it doesn't have to be the same instance of it, because I want a developer who's get some experience and exposure to using those tools in a dev environment could then be useful in a production environment, could actually sit with an ops person if they're not the ops person as well, to understand what's going on. So you want to pick a vendor whose pricing scheme allows you to have the same tool everywhere. The reason I'm being really clear about this is because some vendors, the way they price means that you end up in situations where an organization picks one tool for production and they can't use that tool in dev or QA. It might be a brilliant production tool, but if the pricing means you can't use it in dev and QA, get rid. Find something that lets you do that.
Thank you. You mentioned before, earlier in our conversation, Flux. And somehow Flux and outcome for me just pushes me to think about continuous deployment, to getting quick in front of your users, to have that quick feedback loop. And now you mentioned different types of environments. And there are a lot of movements nowadays about just get rid of the QA, the staging environment, just go production, go continuous deployment. What do you think about these things? Are they useful on the route or not?
So there's a difference between static environments and ephemeral environments. So if I'm thinking, when I talk about my CI environment, what I typically, that's an environment where effectively I'm probably, as I'm doing a build of, say, a service, I'm deploying that service probably in spinning up some infrastructure temporarily to support it, running a couple of tests on it, and it gets shut down again. So that environment isn't static, it's gone. But that doesn't mean I still don't want to get the logs from that, or I still don't want to get the telemetry from that. So for me, I think ephemeral environments make an awful lot of sense. I think having a lot of environments between you and production doesn't make a lot of sense to me. For me, though, that you have to understand why those things exist. What is the purpose of all these environments? So sometimes the environment itself can be the problem, but typically the environment is a symptom of an organizational issue. Environments represent Conway's law as well. Oh, the integrated test environment is really painful and it keeps flaky. We have always people working in it. It's a real issue. So we need to get rid of it. No. Why does that exist? What is the delivery process which requires that? Because yes, we could maybe make some improvements to it potentially, but you need to understand why is it there. So I think often our environment issues are really just symptoms of an organizational or a process issue.
Okay, that's nice. So that means is definitely it helps to have an environment where you can just test it, to just probe the way how your system will behave. But it's pointless to have an environment that is most of the time unused. Ephemeral environments are a good middle ground to avoid this kind of waste from that perspective.
A couple of the quick things on that. Like if you've got like an organization, we've got 10 teams and they're all building microservices and you've got one massive system, a developer should not have to run all the microservices, right? A developer should only ever have to run the microservices they're working on. I shouldn't have to run all 1,000 microservices just to do my local testing. That's wrong. You've got to fix that. So you've got to get good at stubbing approaches. Stubbing most of the time, not mocking. People mock way too much. That's one thing. I think another place where ephemeral environments can work really well for some of my clients, they're really well as sales tools. So in environments where you effectively have to do single tenanted customer installations, having ephemeral environments for that is amazing. You pop in before the sales call starts, press the button, 5 minutes later, you've got a test environment for that customer. Those things are amazing, right? The whole ephemerality of it, though, comes back. Ephemeral or not, the principles are still the same, which is all the configuration for how that environment is brought up and how that environment has been changed needs to be version controlled and automatable and traceable. So if you're adopting that infrastructure as code approach and you are controlling and limiting, if not eliminating, any manual edits to that environment that bypass version control, those fundamental principles have not changed. That was the stuff that's been, there since year dot. It's in the continuous delivery book. More people need to read the continuous delivery book. Keith's book on infrastructure as code is in its 3rd edition. Please read it. That stuff has not changed. So whatever your thoughts about if your environment is ephemeral or not, that stuff is still the same.
Thank you. Good. Anything else that I failed to ask you that we should put out there?
Well, a couple of things. So firstly, I do a newsletter, which I do once a month. You can go over to my website and sign up. It's pretty low traffic in terms of, I try and keep it quite nice and brief. I give updates about how the book's going. I also share information about what I've got coming up and things that I found that are interesting that week or that month. I try and keep it high signal, low noise. If you want to read the current version of the book, which is an early access form, you can go to my website and there's links through from there. You could basically go and access it as early access on O'Reilly.com. That's probably it, really. If you want to find out what I'm doing, if I'm going to a conference, it's in the newsletter. And if you want to read the book, go to my website and find out how.
Okay. Thank you, Sam. Thank you for your time and looking forward to reading your book.
Thank you so much.